Look like a fun ride? That is one fun ride. That is a good time. After about 2 minutes, these big solid rocket boosters would break off. They would come down in the ocean and be reused. See the 3 main engines still lit? Those go for about another 6 minutes. And in 8.5 minutes, you're going 25,000 kilometers an hour. It's fast. It's way faster than taking off in an airliner. And then you get to do parallel parking at about 7 kilometers per second. So you really got to be a little careful with this thing. We fly with some instrumentation, but we also fly by eye. And you'll see in the artist depiction, we come right up and very gently connect to the space station. Now in this particular mission, we were bringing the third crew to live on station and bringing home the second crew who had been living on station. And we were about 4 or 5 months late. So the poor second crew was beginning to worry that nobody was ever going to come get them. So you'll see they're very happy to see us. Thank God you came to get us. That's your Usachiev. He's a wonderful cosmonaut and a good friend. At that moment, we had set a record for the most number of people in space. We put 10 people in space simultaneously at that time. And being NASA, the first thing we do once we get over their happiness that we came to get them is we start with a safety briefing. So you'll see us talking about don't hit that big red button and don't hit that big red button. What to do in the case of an emergency, who goes home on what vehicle. And then we get right down to business. And the interesting thing is the work that you actually do as an astronaut isn't rocket science, right? What you're doing is being a technician. So we're fixing some battery chargers that had gone bad. We're repairing some radios that had a faulty wire that had popped off. We're putting mufflers up because the space station was loud with all the fans. The doors in the space station squeaked. So we had to fix them, right? It's not rocket science. Here's how we were trained to deliver food. Here's how you actually deliver food. So the trainers don't know. The trainers haven't been there. And so their concept of how you're going to get a task done is very different than what you actually do to get that task done. So we're still learning how to work and live in space. Now it's time to go outside. We spend about a day getting the tools together, putting all of the pieces in place that we need to be able to leave the warmth and the air of the shuttle or station and go outside into the vacuum of space to become satellites into ourselves. Getting dressed in the morning takes about 2 hours. So you got to put all this underwear on that has cooling units and that sort of thing. There's on the order of about 200 individual steps that need to be accomplished, and you don't want to skip one. It's bad to skip a step when you put together your spacesuit. So we had a Marine colonel actually with us, who I felt very confident. Marine colonels are very good at making sure every step gets checked. Here it is. This is the moment that I had spent my entire life dreaming about. I dreamed about going to space, but the culmination of an astronaut's career is the chance to go outdoors. To reach over the sill of a vehicle, to ride on a robot arm, and to look down at the Earth with nothing but a bit of plastic between you and the planet, and to appreciate the beauty of this place that we have. There's no photograph that can show you the intensity of colors that's actually the Earth, because cameras don't appreciate it the way our eye does. Things go wrong during a spacewalk. This is actually an example of us using a tool we hadn't planned to use. There was a bolt that just wouldn't go. But you have skills training, not just choreography, and you make do, and you fix it, and you make it work. And you do it together with a team. You don't solve all the problems by yourself. Come back indoors. Bones and muscle have a tendency to get weak in space, so we do some exercising. There's not a lot of free weights, but there's even a treadmill. And you'll notice on this treadmill, he's using a bungee cord around his waist to hold him down. Because if you don't, you can't run on the treadmill. You just float away. This is my friend Tammy catching lunch on the fly. This is stupid astronaut tricks. I used to pretend this was a science experiment. That's me. This is not a science experiment. This is stupid astronaut tricks. It's fun. It's fun. You go to space and you work really hard and you do all these things, and in the end, you have fun. We danced in 3 dimensions. We danced in 3 dimensions. Think about that. You can fly like Superman. It's magic powers. And the food's not bad. The food's nowhere close to what we had for lunch, but it's not bad. Okay. And you can play with your food. Scott didn't want his mother to see this video because he's playing with his food. He said, Dan, we can't put that in the video. My mother will see it and yell at me. Finally, time to separate. Station becomes a vehicle unto itself. Space shuttle becomes a vehicle unto itself. When you look down on the space station, actually it's quite a bit bigger now than it was there. It's like this beautiful golden bird. Golden wings and silver body. It's gorgeous. Yep, this is called feeding the commander the day before entry. So I'm telling Scott that he has to eat the M&Ms with no hands, just to show me he's dexterous still. I brought magnets to space, and if you remind me later, I'll tell you some of the surprises that happened when I put the magnets out to float and find each other and clap together. It was pretty interesting. This is my favorite thing to do in orbit. So Tammy, who was on her 5th space shuttle flight, was teaching me how to drink our juice out of the air. So you squeeze the juice out of the bag, and it floats like a red rubber ball in the middle of the cabin. You punch your straw into it, and you drink your juice out of the air. No container, right. And you all are studying physics here. You all are studying engineering. Look at the dynamics of the liquid as Tammy puffs on the ball of water. Think about that. That's a really interesting physics problem. What are all the modes of oscillation of that ball? What is the issue of surface tension holding it together? And by the way, there's goldfish that she put in the ball, but they're just cracker goldfish, so they're not swimmy goldfish. So no animals were injured in this experiment. So we're pushing this ball around the cabin and having a generally good time. And the rest of the crew hears all this laughing and giggling going on, so they all come back. And this is an astronaut party. Fruit juice and 5 friends sipping through a straw. So I wanted to, because you all are scientists and engineers, I thought you'd be interested to see how surface tension works in space. So these are 2 different types of juice brought together with a string. And it really shows kind of how mixing can occur. Yeah, exactly. Look at that thing. Now, you have to drink your experiment, and it actually tasted terrible, but I pretend it tasted good because it was on video. So. Student experiments. We do a lot of student experiments. This was Starshine, a ball with about 1,000 individual mirrors, all polished by students in grade school, glued together by students in high school, and then the sun reflects off them so college students could track the orbital mechanics for about 6 months. Entry. Entry is as dynamic as launch, and instead of being 8 minutes, takes 45 minutes. And as you hit the atmosphere of the Earth, plasma balls start to pop off the tail of the space shuttle, and nobody mentioned that to me. So I'm seeing these balls of fire shooting around outside, and I say to the rest of the people, is that supposed to happen? And the veteran crew is like, yeah, that happens. And then St. Elmo's fire starts running around the inside of the window pane. You see balls of green and blue and red fire inside the cabin. Is that supposed to happen? Yeah, that's supposed to happen. The space shuttle, when it hits the atmosphere, slams down. The whole thing rattles and shakes because you're hitting the atmosphere at Mach 25. And I didn't even ask if that was supposed to happen because nobody else was getting worried, so it must be okay. Right? It is a glider from 12,000 kilometers away. Actually, the last burn is just past Malaysia. It's a glider. There's no engines. This thing glides all the way to the runway, and if you miss, you die. So you got to hit it the first time. And the thing is a horrible airplane. It's a great space plane, but as an airplane, when you land at the airport, your aircraft lands at about a 3-degree angle. This thing lands at a 21-degree angle and about twice as fast. So 7 times as steep and twice as fast, and you get one shot. The landing gear don't even come out until you're 300 feet off the ground. And if the landing gear don't come out, you don't survive. So this is not trivial. But it works. And remember, the guy who's flying it, this is often the very first time he's ever flown that aircraft. Say, what? Because there's no practice shuttle, right? Only if you've been a commander more than one time have you ever flown it before. So the first time the man puts his hand on the controls is often the first time he ever flew it. And he's been in space for 10 days, so his head is spinning around in circles. And the thing flies at 7 degrees steeper than an airliner, lands twice as fast. And, you know, on my second flight, the commander said over the comm, I can't see the runway, which is disturbing to the rest of the crew. And he realized what he said, and he goes, but not to worry, it's just a cloud. He popped through the cloud, and we were able to land. So it's a testament to the adaptation of the human body. We adapt to space flight, and yet through training, even though your head is spinning, and this is the first time you've flown the aircraft, and it's 7 degrees steeper than an airliner, it's twice as fast, and the runway's coming up, and there's clouds in the way, every single time a shuttle made it to a runway, it landed successfully. And that's a testament to human training and adaptation to environments. So what happens after you land? After you land, what happens? Well, first of all, it's a little hard to stand up because your body's been telling you for 9 days that if you push hard with your legs, you go flying up to the ceiling and you smack your head. And so I'm in my chair and I'm unbuckled and I'm saying, okay, let's stand up. And my legs are saying, no way. We're not doing that, because the last time we did that, we slammed into the ceiling. So you know, really, legs, it's okay, let's do this thing. You eventually convince your legs to stand up and you waddle on off the space shuttle. And you get off the thing, and the first thing that happens is your friends come up to you and they go, Dan, great flight, nice job, way to go. And while you're talking to your friend, the technician comes along and they hand you your change of clothes. And what do you think you did? You say, thank you very much, and you leave them right there. They don't stay right there. They go boom to the ground. Say, oh yeah, gravity. I remember that. So they tell the spouses, the husbands and wives, when they come home, don't hand them the baby. It takes days to readapt to Earth. I was a surprise for me. I thought, okay, 40 years on Earth, 9 days in space. Maybe it'll be hard for me to adapt to space. But for sure, it'll be easy to come back to Earth. 40 years on Earth, 9 days in space, hard to adapt to space, easy to adapt coming back. I was completely wrong. When I got to orbit, felt like I was born to be there. I unbuckled from my chair. I took my glove off and let it float in front of me because Tom Hanks did that in Apollo 13. I thought that was kind of interesting because he was inspired by the Apollo guys and I was inspired by Tom Hanks as to what to do when I first unbuckled. I should tell him that someday. And I floated up to the window, and I saw the Earth from the first time above the sky, knocked over by the beauty. And I just sat there with my sandwich and my drink, and I watched the Earth go by, and I felt so at home. It's like I was born to be there. I loved it. I come back to Earth 9 days later, 40 years on Earth, 9 days later. I can't walk straight. I was a science fair project for my daughter. She had me close my eyes and try to walk straight, and I'd walk into walls. She said, point straight up, and I would point over here. It took me 3 days to get back to even being able to drive a car. It took me a week to get back to being able to safely fly a plane. And this is an interesting thing. I went back to space 3 years later, spent about the same time, actually more time, about 11 days in space. And when I came home, it took me 1 day to get back to normal. Even though I wasn't doing anything consciously different, somehow my body or my brain remembered the experience 3 years ago and said, we don't have to go through that. And then 2 years after that, I flew again, and I came back and I was better in an hour. So what's going on? We don't know what's going on. We don't know how the brain adapts to that. It's a very interesting question of how it's possible to learn in that way and not even consciously be doing anything different, and yet the body figures it out. Fascinating. So where do we go from here? Right? What's the next step? I'll tell you from my perspective what I hope is the next step, which is I think we ought to go to Mars. I'll tell you why. There's 2 reasons I think we ought to go to Mars. The first one relates to the question that I get every time I give a talk, which is, have you ever talked to an alien? I know you wanted to ask that question. I know you did. And the answer is no, I haven't talked to an alien. And if I had, I probably couldn't tell you anyway. But this galaxy has hundreds billion star systems. And there's hundreds of billions of galaxies. And we're starting to answer the question that we couldn't answer just 15 years ago, which was, are there any other planets out there? We had no evidence for planets only 15 years ago. Now we know planets are abundant. They're all over this galaxy. And there's planets like Earth. We don't know whether or not there's life. We could go to Mars, and we picked Mars because its history is warm and wet, just like Earth, a place where life could arise. And we dig in the Martian soil, and we find any evidence that there's life that ever was on Mars that's fundamentally different than life on Earth. If we can show that life arose independently in 2 different places, we have answered the question. Because if it arises independently in 2 different places, it's all over the galaxy. It's all over the universe. And it's just a matter of listening in the right way to find it. If we go to Mars and we find no life, none, perfectly sterile, no evidence whatsoever anywhere on the planet that life arose, and we confirm what we believe right now, which is that at one point, for millions of years, Mars was wet and warm, no life, and we continue to not find life anywhere else in the galaxy. Our telescopes that go out and look at extrasolar planets don't discover non-equilibrium atmospheres. Well, then you worry that maybe we are it. As hard as that might be to believe, it might possibly be that we are the only life. And if that's true, then the second reason to go to Mars becomes important. Because the second reason to go to Mars is that right now, one event can kill this species. One event, asteroid impact, biological, viral something or other, ecologic runaway, could kill us all because we all live on one planet. Single planet species do not survive. We go to Mars, we make an independent colony on Mars, and we are technically able to do that right now. So that this colony grows and is independent of Earth, then no longer can one event kill us all. And what does that mean? That means the species is immortal. It means Jim Kirk will be born someday. It means Star Trek will happen. It means we'll go to the stars. And we need to go do that. So those are the reasons for me that we should go to Mars. I want to know if we're alone in the universe, and I'd like to see this species go on and invent Star Trek. Thank you very much. Yeah, so the way that the landings are practiced is there's actually a business jet that is configured to have the same cockpit as the space shuttle. But in order to get a business jet to fly at 21 degrees nose down, you have to, and only go 300 knots, what you actually have to do is they put big custom spoilers on it. They drop the main landing gear. They drop the flaps. And then you get to 10,000 feet, and you put both engines in reverse, and you run them at full power in reverse, in flight, with the flaps up, the spoilers up, the gear down, and that allows you to make the same approach in a business jet that you can use in the space shuttle. It's a very strange feeling in an aircraft to run the engines in reverse while you're in flight.
The other thing is, now they have privatized the space flight, SpaceX.
Yeah.
How is the selection of astronauts? Still the rigorous way that you have to go through, or?
Yeah, so that's right. So I think the next ride to orbit, besides Soyuz is currently still taking people to the space station, is almost certainly going to be SpaceX, which is a commercial company that has developed rockets which have already now docked with the space station. And I think that's a good idea. The idea that commercial entities will take over this role of going to Earth orbit, which hopefully frees NASA resources to move on to the moon, back to the moon, or to go to Mars. So if the government can do the things that are not profitable, but having developed the research and technology to go to low Earth orbit, NASA has enabled these private companies to then do it for a profit.
Two more.
Sure.
The other one is, you mentioned about going to Mars. I have another fear.
Yeah.
People are using space as weapon platform. Countries, rich countries will be building space stations but equipping with missiles.
Yeah, absolutely. So militarization of space is an item that comes up right from the original Sputnik. I mean, people thought Sputnik, the Russians are going to put a hydrogen weapon on that and they'll kill us all. And the good news on that is at the height of the Cold War between the United States and the Soviet Union, when both countries were on immediate alert to destroy the other country and in the process destroy the world, they at least were able to reach agreements to not put those weapons in space. And so I think that, actually, to me, that's very encouraging, that at a time when countries had such incredible distrust of each other, the leadership was still capable of recognizing that putting weapons in space was just a very bad idea. And even in that sea of distrust, we're able to sign treaties and stick to them to not weaponize space. And so, we have to hope that that kind of sensibility is maintained.
Last one. The Austrian jumped from the...
Yeah, Felix Baumgartner.
Felix Baumgartner. So is that something that could adapt into astronaut-centric procedure in case?
Yeah, so there's a fundamental difference between what Felix Baumgartner did. What we're talking about is a man that you may have read went up in a balloon went to space effectively in a balloon, and then jumped out and did a skydive from 24 miles. And that goes to the question of why a spacecraft stays in orbit. You notice he jumped out and he fell to the Earth. I went out of the shuttle and I didn't fall to the Earth. You notice that? No, there is gravity. We're only 200 miles off the surface of the Earth, and the Earth's 8,000 miles across. We're in the same gravitational field effectively as we are on Earth. The reason I don't fall to the surface of the Earth is because I'm going horizontally so fast. And the explanation for that is, suppose I were to take a ball and throw it. It'll go a bit, and then it'll hit the ground. Take a ball and throw it faster, it'll go farther before it hits the ground. Take a ball and throw it really fast, and it'll start to come down to hit the ground. And if you throw it fast enough, the curvature of the Earth will cause it to miss. Right? It's the curvature of the Earth that allows this ball, if it's going fast enough, to go all the way around the Earth and hit me in the back of the head. The reason we can't do that right here on the surface of the planet is because when you throw a ball that fast here, the atmosphere turns the ball into a crisp.
I was thinking because of different density. When you take a piece of pebble, you throw across the surface of the lake. Density on the edge, the pebble will skip.
Yeah, but that's not the reason that we stay in orbit. The reason we stay in orbit is because we go so fast, we miss the planet. And the reason we have to go to 200 miles has nothing to do with having less gravity up there. What it has to do is getting out of the atmosphere. Because if you get out of the atmosphere, then you can go the speed you need to go to miss the Earth. And that's why we go that speed. We go 25,000 kilometers an hour because that's the speed that's required to be constantly falling to the Earth and never hitting it. So if you go to the moon, you can orbit the moon from 10 feet off the ground. Right? You don't need to be high in the sky on the moon because there's no air there, and you can go as fast as you want. And as long as you go fast enough to miss the moon as you keep falling toward it, you'll be in orbit, and you'll have free fall, and you'll be floating, and all those things.
Last question.
Okay.
Anything that affect your body after 3 times being in space, maybe you lost something, you lose weight, you lose some sense of...
Sure. So what's the long-term aspect of spaceflight? Yeah, for me, nothing. For me, my body's recovered because I only flew for about 10 days on each flight. And although there are immediate issues with balance and stability and maybe a little bit of weakness, there's really no significant long-term effects. There is some radiation accumulation. Astronauts generally look older than they actually are because of some radiation dose. But people who fly for 6 months or a year have to undergo serious rehabilitation when they get home, and some things never fully come back. The trabecular structure of the inside of their bone is permanently changed. And there are also some suggestions that there may be some permanent changes to the eye that occur in some people who fly long duration flights. So this is really one of the main purposes of the space station, is to discover what are the effects of long duration flight, what's going to happen to the crews that go to Mars and spend a couple of years out there. So it's a really interesting question, what are the long duration impacts? And we don't have a lot of data on it because there's not that many people who have done it. And of the people who have done it, it hasn't been very long since they did. So if flying in space for a year for some reason would dramatically increase your chance of getting a cancer 20 years down the road, we won't know that yet because it just hasn't been long enough and there aren't enough people. It's an ongoing research project. Second of all, the argument that it was fake was based on photographic evidence. And if you go to, these sites might be gone now, but there's very specific answers to every single one of those issues as to, it's not fake because of this. But the really good answer to that question is just recently, I think about 6 months ago, there was a satellite that imaged the landing site and showed that there's a vehicle still there. The vehicle they left behind is still at the site.
And the US flag?
I don't know if the US flag is there because it's too small to see. And it's very possible that when they launched, the US flags got blown over. So that's a little hard to know. But there's no doubt that there's a vehicle sitting there. The other thing is, I think that to fake something of that magnitude actually would have been harder than going. Seriously. And the final answer is that I know the people that have flown on the moon, who went to the moon. And we have lunar material that they brought back. And it is 100% for sure we did go to the moon. So it's not let's look at the evidence on this side and evidence on that side. It's a myth that it was a fabrication. It's a joke. And anyone who actually has looked at the data and not just listened to the tabloids who are trying to get attention, if you seriously look at the data and you seriously look at those photographs, there's absolutely no reality in the idea that we fabricated this thing.
Yeah. But for me, it's still, again, the easier answer is to do it again to prove them wrong. But anyway.
Well, I don't think that doing it again would prove anybody wrong because just because you do it now doesn't mean you did it before. But I think it's a pretty good proof that you can image the sites that we landed at and see the vehicles and, And someday on the moon, there'll be, that'll be a museum site, right? They'll put ropes around it and you won't be able to go up and touch it anymore.
Okay, well, second question, I'll make it fast. It's about the space tourism.
Yeah.
I just want to know, right now I've seen Virgin Galactic doing something about making it cheaper and much more affordable for people. What do you think about the future of this industry?
I think it's great. I'm really looking forward to the commercialization of spaceflight because, as I said to you, the Earth, you can't see the beauty of the Earth. The beauty of the Earth is not revealed in photographs. And I think that if more people went, if we could get more people in space and see this global perspective, if more people could understand how fragile our atmosphere is because they've seen it, and how beautiful the Earth is and how you don't see national borders, I think it could make the Earth a friendlier place to be. And I think people would appreciate the beauty and the ecology of the Earth. And so I am very much in favor of commercialization of spaceflight and getting as many people as possible to see the beauty of our planet.